Hello guys. In today's session, I'm going to cover about the NAT, that is basically the network address translation. This is one of the very important concept in field of the F5 because whenever you see about the traffic which is traveling from the any of the client which is on the internet, so I'm just referred here that is basically on the client that is on the internet, and if any user with having some of the destination IP address tries to send some traffic that's basically landing on the F5, and then it just translates its IP address to the actual server IP addresses. Sometimes we need the IP address, the destination IP getting translated, and sometimes we need the source IP getting translated. So it becomes very important. So I'm going to focus that what basically the network translation is. And after that, in the next session, I will talk about the its implementation in the F5. So this is going to be a theoretical session about it. And then in the upcoming part, I will explain about the implementation in the lab, that how basically you can configure in the F5. All right, so let's learn about it. Let me minimize this window. So first, that what is NAT? So NAT is basically a translation of the IP address. It could be from private to public or public to private. It doesn't matter. So any translation, basically translation of an IP address, that is known as the NAT. So sometimes people call it as like private to public or public to private. It's not at all something, nothing like that. Okay. It's always translation, because whenever, let's suppose, your traffic going from your network, right? Let's suppose this is your personal laptop that is having some private IP address, and then it goes to the internet, it converts to the public IP address. So it has some translation from private IP to public IP address. But when the traffic comes back, it again translates from the public IP to private IP address. So this is like very basic concept you learn in the CCNA. That's what I'm repeating. That's why I'm not going too deep in that one, but I'll just remind you of it, that what basically it is, and then how we can implement in the F5, because our this is entire codes of the F5 load balancer. So we will try to map it according to the F5 load balancer. Now it's if you remember, there are like three parts of the network address translation, and one of them is the static NAT. Second part is your dynamic NAT, and third is PAT, that is also known as the port address translation or NAT overload, right? So we also call it as a NAT overload. So it just depends persons on that what they want to say it, but they can call it at like anything. Either it is static NAT, dynamic NAT, sorry, like these are one of the three types. One, two, three, and third one can be called as the port address translation, or it could also be called as the NAT overload. This is the reference that on which side the IP address is getting translated, right? So either its source IP is getting translated, or its destination IP address is getting translated. Because whenever any IP packet is traveling, it has two fields, right? Source IP address from where the traffic is coming, and another at the top, that is the destination IP address, that to where basically it is going. So if you are accessing anything from your laptop, you are trying to access the google.com, right? So the Google IP becomes your destination IP address, and your IP becomes your source IP address, right? So basically, we want to bifurcate that which of the IP address you are translating. Either you are translating the source IP address, or you are translating the destination IP address. So if you are translating the source IP address, it is called as the source NAT. And if the destination IP is getting translated, then we call it as a destination NAT. So these three parts, they can land in any of the way. Either they can be here static dynamic NAT and PAT, that's also possible, like static NAT, dynamic NAT, and the PAT. But most of the time, what we are doing, we are doing these PAT at the source side whenever we're translating the source IP address. I'm talking about the probability, maximum chances we are doing this PAT, port address translation. Hold on, I will explain you that what are these if you don't know static, dynamic, and PAT in just very short and crispy. But I will explain you in a while. But I'm just talking about that. That is highly used in case of the source net because your traffic is getting going out of the internet. So for the saving your IP addresses, we are doing this one. While in the destination net, where your destination IP address is getting translated, that there we are using our static NAT at the highest. That is one to one mapping. It's not like it is like not a rule. It basically we call it as a thumb rule that more we do it, that is static NAT. We can also do dynamic or pad. Nobody is stopping us. But these are the like I'm talking about the probability that mostly people are configuring these. But if you want to configure a static NAT in the source IP address, nobody is stopping you. Options are available. You can do that. And here, if you want to do use the patch, nobody is stopping you. Options are available for the configuration. You can do that. Perfect. So now let's talk about the static, dynamic, and right. So very first, that's static NAT. Static NAT means one-to-one mapping. Okay. So it's like, for example, your laptop is having an IP address of 192.168 1.10. Okay. But obviously, this is your private IP address and it cannot go to the internet. This is not routable. All of the ISPs block private IP addresses at their edge routers. So you cannot go to the obviously like you have divided right private IP address and public IP addresses. So private IP address cannot go to the internet. So now if you want to access the internet, you have to NAT it. You have to do the translation from this private to public IP address. So that's what basically your broadband routers, right? You have some broadband routers having Wi-Fi connectivity there. So there, those routers do their translation. They convert it from this private IP address to public IP address. So how basically they will use it? They have the your service provider. Let's suppose you have taken from the any internet service provider. Let's suppose Airtel, Geo, or like any T-Mobile. Like if you're in different countries, so different countries, different providers are there. So whatever Telstra, so any provider, whatever they are, they will have some public IP address. So let's say they have a public IP address of 20.20.20. So you have to translate it, then only you can go to the internet. So now what you do, you convert this your IP address static. You put the configuration that this IP address, whenever it is going out, please translate it to this one, this IP address, and then go to the internet. So that's the one way you can do the fixed mapping that whenever this machine is coming here, map it to this one and go to the internet. But the problem is with this static NAT is that you can use only one laptop here, right? But in your broadband, you have like multiple machines. Sometimes you're using it, sometimes you're not using them. So for example, any other machine comes here, you're connected your mobile phone with the Wi-Fi, having an IP address 1.11. How this will go to the internet? It cannot go because you have only one IP. Then you need one more IP like 20.20.20.21. So by like getting this public IP address also you have to pay the amount for that one. It's not feasible. You have to pay like a lot of money to buy this public IP address. That's not a feasible solution. for the internet. Okay, so what people did they do? They use a single IP address and add a port at the end. But before that, that's basically third part, that port address translation. I will not jump onto that one. But before that I will talk about that. But this is the problem, right? To understand that now, if you have like even TV connected, having an IP address 192.168.1.12, they need the third IP address. Let's suppose they need a 20.20.21. Your TV connected, then TV need another IP address 20.20.22. So it needs like static IP addresses. You have done static mapping, and every new machine comes, they need one specific IP address to go to the internet. And that's like vestige of your public IP address. We are already having a shortage or like limited IPv4 IP addresses, so we can't do that one. So what are they going to do? There's an option like a little bit flexible, but better than the static net. Okay, what we did, rather than using our this method static one, what we said that okay, we will do the dynamic net. So what happens with the dynamic net? I said that I have like four IP addresses, like four machines, my laptop, my mobile phone, my TV. Let's take, I have two laptops or personal computer as well, 1.13, three machines, right? And now if they want to go to the internet, so they need a public IP address. So I was having a lot of money. What I thought that let's take two IP addresses. So I took two IP addresses from the any government body, like any of the governing body which is providing an IP address. I took 21 and 20.20.20.22. I took two IP addresses for my simplicity so that I can use the four devices. So now how basically we can access the internet using the dynamic net? Rather than the static mapping, we have the pool of four devices here and pool of two public IP addresses available. So two public IP addresses, two public IP addresses. So if the first guy he wants to access the internet, like because not first guy basically, the if I want to access the internet for my PC, or this is a laptop, right? I forgot. So if this is a laptop, if I want to access the internet, I will come here, I will pick up the one IP address from the pool and go to the internet. Same time I connected to my mobile phone. So I went to pick up one IP address, came here, pick up one IP address and went to the internet. Now if I need to access the TV, I want to watch the movie now on 1.12. This is TV, right? So if I want to watch the TV, then what I'm going to do? Because now if I go here, I do not have any IP address available. How will I access the internet? So what I did, I disconnected. I shut down my laptop. I shut down my laptop. This IP got free, the first one. Then it used that IP address and that went to the internet. While in the first one, static one, what was the problem? You mapped statically that, okay, this is configured, attached to this IP address. Even if you have shut down your laptop, you cannot use that IP address. So that was the problem with the static NAT. That problem got solved with the dynamic NAT. But still the problem persists that we cannot utilize the IP address efficiently. The problem is your large utilization of the public IP addresses, as we cannot afford this much of IP addresses. These are like four devices. For example, you are in any of the organization, or you're just think of like you have uh, you 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 are living in a city, not city, like a small area. Let's say about the society, right? One tower in your building, like they are living like 100 families. We cannot afford providing 100 IP addresses for one society. We can solve within a single public IP address. 100 family. So that solution comes with the PAT. Okay, so we cannot afford to provide one public IP address for each individual machine. The solution is the PAT. Let's understand that how basically that works and how basically you can save your IP addresses. So if we go to the PAT, right? So what happens in the PAT, that is a port address translation. For every IP address, we add a port. 92.168, 1.10, 192.168, 1.11, let's suppose 1.12, 1.13, could be multiples. And I took only one public IP address this time. All right. What is going to happen now if this guy, first guy, wants to go to the internet? What he's going to do? He will come here, pick up one IP address and add the, whenever it is going to the internet, it will add one port number 20.20.20.20, and at the end I will add some port number, something like 6000. Okay, so now it can go to the internet. Next user comes. Okay, next one came. If he wants to go to the internet, he will pick up the same IP address. He will use like 7000 port number. Any, these are like from one to not one. It's like from, let's suppose 1224 ports are reserved, and but it's still like thumb rule is something like you can use the port number between 10,000 to 65,536, something like that one. 500. I don't remember the third count, but something like 65,500 something you can use these many of numbers. I will write zero like this. 65,500. 32 or 34 is there. I just missing that number. Okay, so they are basically these many of the port number you can. So this is still like something like approx 55,000 port numbers you are having, right? So I'm just taking like 6,000, but you can use 6,001, 6,002, 6,003. That also works. So we have these many of the ports number available, and using the same IP address, these users can go to the internet. Like 7001 will also work. So we add a colon at the end. We call it a socket, and that's how it goes to the internet. So you see that magic, even using the single IP address, we can serve 55,000 devices to go to the internet. So that's basically the effective utilization of your public IP, and that's how we do it. So right now, whatever we were doing, that where basically we were doing the source IP getting translated. We never translated the destination IP till now. Okay, so if I go back to the image, whatever I was showing you at the beginning, right? This image. Now, if your traffic is coming from here, let's suppose your IP address is here, something like 20.20.20, having some port number 6000, right? And you were accessing something on the F5. Let's suppose you were coming to my organization, that's like Sapiem Security or Fresh Developer, anything, any of them. And there I have uh, given you a public IP address 100.1.1.1. Okay, that whenever you wants to access my servers or like my web page, sapiemsecurity.com, you will be coming from this IP address and you will be hitting this. So like basically I will say that sapiemsecurity.com is having this IP address. Okay, so basically you are targeting this IP address. Once it's launched on this F5 LTM, because this is not the actual F5 cannot serve that request, that has to go to some backend servers. So this IP address will be translated to the actual IP of the server, which is basically something like 172.16.1.10. And this could be like 172.16.1.20. So this IP address will be translated from 100.1.1.1 to 172.16.1.10. 10 whenever the request is going to the first server. Okay, so it's basically what you are doing here. You are doing the destination IP translation, DNAT, I will say, right? Because the source IP you already done when you are accessing the internet, you are going out of that one, you already did add the port number. Now at our side, it's like server side or F5 side, I'll be doing the destination NAT. All right, so I'll stop it here. In the next session, I will show you that how basically this destination IP address is getting translated. More theoretical part if I will do the packet capture, and I will show you that this how this IP address is getting translated from to this actual server. All right, guys, I'll stop it here. See you soon in the next session. Meanwhile, I want to tell you that there are some other recorded sessions available on my website. This is my website, freshdeveloper.online. Okay, so here you can look on to the different courses like cybersecurity, FortiGate firewall, checkpoint, F5 LTM is also available. You can go there and learn according to that one. And there are some paid classes as well, live classes. So for that one, you may have to pay. You can go for that one, and you can contact me on this WhatsApp number. This is my WhatsApp number, or you can reach me over email. I am also like recently moved to the new website, that's cpmsecurity.com. So like homepage is still under development, but my actual learning portal is live. So I'm also taking live classes over there. So that's just an information. I'll stop it here and see you in the next video. Till that, bye bye. And yeah, if you have any question, feel free to write in the comment section. I will get back to you as soon as possible. Bye.